Hey guys, Mr. Smith here. Here to walk you through Module 2, a little review of factors and multiples. Hopefully you've picked up this sheet off the back. These are some doodle notes for you. There's a front and a back to them. They're hole punch. They're really going to be important to you, so you're going to keep them in your notebook when you're finished. But today, you're going to be able to go through this video at your own pace, pause it if you need to, and get the doodle notes down for this video. So make sure you take good notes. Hopefully, this is a review, clears out some cobwebs, and we'll go from there, okay? So Module 2, Factors and Multiples. So what's the difference and how are they found? All right, maybe you're feeling like this guy right now. So we're going to start at the top of the page on multiples. So what exactly are multiples? Okay. The first thing to understand about multiples is that there is a multitude of multiples, which means that there's infinitely many. Okay. So multiples go on and on and on and on and on. And to find these, again, make sure you're getting this down. To find these, we're going to multiply. So down here, to find multiples, we multiply. So here we got the number 16 we're going to use as an example. So the first multiple of 16 is to multiply it by 1. And that'll give us our first multiple. 16 times 1 is 16. Our second multiple, we're going to multiply by 2. Now what's 2 times 16? 32. Again, multiples, there's a multitude, it'll keep going. We're going to multiply by 3 for our next one. So times 3. 16 times 3, I'm going to help you out here, okay, just so we can get the notes, is 48. We're going to multiply by 16 to get another multiple. 16 times 4 would be 64. 16 times 5 would be 80. All right, and then you look down here, there's many more. How are we going to get them? Well, we can multiply by 6. We could multiply by 7. We could multiply by 8. We could multiply by 1,000. Okay, we can multiply by any number, and we're going to get a multiple. Over here on the side, it says numbers only count as factors or multiples when you multiply or divide by integers. So we're not going to get a multiple if we multiply by, let's say, a fraction, right? So 2/3 times 16 isn't going to give us a multiple, or even a decimal. All right? So that's our multiples. Remember, there's a multitude of them, an infinite number of them, and we get them by multiplying that original number by 1, by 2, by 3, by 4, by 5. At the bottom half of the page, we have factors, okay? And then again, these are two things that a lot of kids mix up, so I'm hoping these notes can help clear out some cobwebs and can be a reference point to you. So with factors, there's a fixed number of factors, all right? In other words, there's a limited number. There's only so many factors that a number has, okay? So with factors, to find factors of 16, we're actually dividing. We're thinking, what can we divide 16 by? So let's start off, we'll go with, well, let's see, 16. I know I can divide 16 by 1, and if we divide 16 by 1, we get 16, okay? And this we call a factor pair, because we could multiply these two together. 1 times 16 would give us 16. What else? Well, I see that this number is even, so I know right away I can divide it by 2. What can I divide by 2? Well, let's see. 2 times what would be 16? Oh, 8. So there's another factor. So far we have 1, 16, 2, and 8. Let's see. Now what? 16 divided by what else? Well, if I know my facts, I know I can divide 16 by 4. 4 times what is 16 is 4. So our factors of 16 are 1, 16, 2, 8, 4, and 4. And if you think about it, when you're finding factors, they're really like peas in a pod. Okay? So here we have our 2 peas inside of our pod, inside of our pea pod. So there's always a factor pairs, right? And individually they make our factors. Okay? Again, factors come in pairs. So let's move on and let's try a few. So this says list all the factors and the first 4 multiples of 72. Okay, now you're gonna have to write kind of small because we don't have a lot of room here. But let's first list all the factors of 72. Okay, so I a lot of times think the easiest way to list factors is to think about all the numbers that I could possibly multiply to get 72. So let's see. Well, I could do 1 times 72. That would be 72. it's even, so I must be able to take 2. Let's see, 2 times what? 2 times 36 is 72. Let's see, here's a little trick. It's able to be multiplied by 3. How do I know that? Well, if I add 7 plus 2, I get 9, and I can divide 9 by 3, which means I can also divide 72 by 3. So then it's just a matter of figuring that out. Let's see, 372, let's go with 24. And again, if I'm not doing this along with you, you'd take 72, you'd take 72 and you'd divide it by 3, right? And we do it this way. Let's see, 4, 7, 4. This is a tricky one, but actually, yeah, 4 times 18 is 72. This is the most common one, or we should know this one, 6 times 12, right? That's our 12's times tables. And let's see, any other ones? Oh, yeah, 8 times 9. Okay, those are all the factors of 72. Now, when we list these, they're kind of all jumbled up, right? We want to list them in order. So we're going to say, okay, 1, 2, 3. So 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. So 18, 24, 36, 72. And again, I know this can be cramped in that box, so if you're out of room, you could always pull out your notebook and take these notes in your notebook, take these examples down. Now, you guys could relate this probably back to at one point you did factor rainbows, right? So you can rainbow this if you want to, right? But I'm not going to rainbow them. All right, now there's all of our factors, but this says also, and the first 4 multiples. So let's list the multiples of 72. So, well, we know that 1 times 72 is 72. 2 times 72, I'll help you out here, is 144. 3 times 72 is 216. 216. 4 times 72 is 288. So these are the first 4 multiples of 72. Okay? List all the factors of 45. So again, let's go over here. Let's think of 45. Well, let's see. 1 times 45. 4 plus 5 is 9. 9 is divisible by 3, so we can obviously take 3 into this. 3 times 15. It's not even, so 2 can't go into it. 4 can't. 5 can. 5 times 9, right? And I think that's it. So our factors, again, we're going to list them. 1, 3, 5, 9, 15, and 45 are our factors of 45. Okay. List 5 multiples of 8. So it doesn't say which multiples. I'm just going to list the first ones. So I'm going to do 8 times 1, times 2, times 3, times 4, and times 5. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. And 8 times 5 is 40. So there's the first 5 multiples of 8. Again, there's a multitude of multiples. There's an infinite number because I could multiply this by 6, by 7, by 8, by 9, by 10, all the way up to by, whatever. I can keep going and multiplying. If you have to pause, go back, rewatch, just feel free to do that. You can do that on the screen, right, to get all the notes. So let's talk now. We got two different things we're gonna hit here. Least common multiple, greatest common factor. All right. So the least common multiple of 2 or more numbers is the lowest multiple that they share or that they have in common, and that's that word common. Like if you have something in common with your friend, it's something you both share. Maybe you love sports, you love reading, you love art, maybe you have the same hair color. So when you have something in common, you share it. If it's the least common multiple, it's the lowest multiple that you share. Okay? On the flip side, whoops, look down here, greatest common factor. Again, you have something in common. It's the greatest factor that you share. So to find LCM and GCF, first you either list the factors or the multiples, whichever you're asked to do. You look for the matches, which ones do they have in common, and you find the least, if you're doing the least common multiple, or the greatest, if you're doing greatest common factor, of the matches that you've been requested to find. okay? So let's try it. Here it says the LCM of 9 to 12, the least common multiple. Okay, so I'm thinking multiples. There's a multitude of multiples. I need to multiply with multiples, so here I go. So for 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. Now I'm going to go down here to 12. I'm going to catch it up. 12. 12 times 1 is 12. 12 times 2 is 24. 12 times 3 is 36. All right, no match yet. 9 times, what am I doing here? Oh, 9 times 4 is 36. Oh, stop. Here's a multiple that they share. It's the lowest multiple that they share. So our LCM, oops, of 9 and 12, ignore that, sorry, is 36. On the flip side, we do the greatest common factor, right? So we're going to list all the factors of these numbers. So we're going to do 1 times 40. It's even, so I know I can do 2 times 20. 4 plus 0 is 4. 3 can't go into 4, so it can't go into 40. 4 times 10 is 40. 5 times 8 is 40. And that's it. I'm going to go over here and list the factors of 64. Well, I know 1 times 64. I know it's even, so 2 must be able to go into it. Let's see, 2 times 32. 6 plus 4 is 10. 10 is not divisible by 3, so either is 64. 4 can probably go into it. Let's see. 4, yep, times 16. And again, that's just something we'd have to try, right? We'd have to see, can 4 go into it? And you'd find out it goes in 16 times. 5, no, doesn't end in a 0 or 10. 6, no. 7, 8. 8 times 8. So now if we're finding the greatest common factor, here's our factors. We're going to find the greatest one that they have in common. Well, they share a 1. They share a 2, right? They both have a 2. They both have a 4. They both have an 8. And I'm looking, studying them real close so I don't miss any. Looks to me like the greatest one they share is 8. So the GCF of 40 and 64 is 8. Okay? So remember, pause, go back, rewatch, and try to see what you can do here as far as memorizing these. Okay? How do we find the GCF? How do we find the LCM? What is a factor? What is a multiple? Hopefully this paper and these doodle notes will help you. Feel free in your own time if you want. You can color it, make things stand out to you, whatever you want to do. Down at the bottom, we had a couple examples. Find the GCF of 9, 15, and 18. Find the LCM of 7, 9, and 21. And then find the GCF of 14 and 28. So I'll give you a little hint on this one. I'm going to have you try them on your own, but I'll give you a hint. So this is 7, right? And there's 3 numbers here. So we're going to have to find the multiples of 7 and 9 and 21, and they have to all share the same one. So if you start out through here and take these each times 1, each of these times 2, times 3, times 4, times 5, right? If you take them each times those numbers, you're going to start filling this in. Here's your 7 multiples, here's your multiples of 9, here's your multiples of 21. Somewhere you're going to get a match. Okay? So what I want you to do at this time is pause the video. I want you to solve for 1. I want you to solve number 2, and I want you to solve number 3. Over here, number 1, you're also going to have 9, 15, and 18. Okay? You're going to find the factors of each of these and look for the greatest one that they all share. What is the one that they all share that's the biggest one they all share? Pause the video, solve this, okay? And then in a second, I want you to restart the video and I'll reveal the answers. All right, so the GCF that you should have gotten for this one would be, the GCF would be 3. Your LCM of 7, 9, and 21 would take you a little while, but it would be 63. And your GCF of 14 and 28 would be 14. So hopefully you did well on those. If you're saying, ooh, didn't quite get that, you can see me for help. And then you can move on to your homework for tonight, which is going to require you to do the exact same thing, finding GCFs, LCMs, factors, multiples, all that. So make sure you refer to this sheet, okay? Good luck. Work at your own pace. I'm here if you need me, and have a great rest of your day.